information is given in terms of gram. And then for NOBR, for the reactant, but the question is asking for BR2. Okay, nampak tak? Ini of course you kena ada stoichiometry. So the question is given for the information is given for NOBR, but the question is asking for BR2. Okay, so for this one you need to have a relationship in order to relate these two. Okay, all right. So I would go for the differential rate. Okay, yang 1 per negative 1 over 2. I would go for this one first lah. Okay, I will go for this one. Okay, so that is the relationship. So this is the volume already given. The delta T is already given for you to calculate the rate later on. Okay, all right. 1 over 2 delta NOBR. Allah Akbar, delta T, and then dia nak tahu BR2 kan. Alright, so delta concentration BR2 over delta T. Okay, so this is the relationship that we have so far. Alright, now what we want is the rate, of course. Soalan menyusahkan hidup kita. Okay, it's not given directly, but we have to kita kena carilah. Okay, so what we have is the mass. So you have to convert in terms of concentration. Okay, one more thing that you should realize is that what you want is delta NOBR, right? Okay, and also delta T. Delta T is not a problem. It's 5 minutes lah. The delta T is 5 minutes. And how about delta NOBR? You want delta NOBR. You bukan nak concentration NOBR. What we want is the delta. Okay, read the question carefully. Dia kata decomposes. Okay, for example, concentration awal is given, concentration awal is 0.5. Concentration, this is concentration awal lah. Okay, concentration after 5 minutes, for example, is there, of course, it will decreasing, right? So 0.2. Okay, all right. So this is at the beginning, and this is after 5 minutes. So bila dia cakap decomposes, the one that has been used. Maksudnya decomposes ni is already delta concentration. Decomposes maksudnya dah degenerate, dah hilang. Daripada 0.5 becoming 0.2. Mana dia pergi? So itulah maksudnya yang dah hilang, yang decompose. So in order to get yang berapa banyak decompose, 0.5 minus 0.2 will be 0.3. This is what it meant by decomposes. Faham? That's why every time saya cakap rate is equal to delta. Bukan concentration tau. It's equal to delta concentration. So what we want is the delta concentration. So fahamkan soalan tu, oh decomposes. So it meant that this one is the one that yang hilang, yang gone already. Maksudnya it is the delta concentration lah. This one is the delta concentration. You have to change into concentration lah. This is in gram, right? Okay. So you have this one, you have this one, you can insert directly. Okay, you can insert directly so that you can get the BR2. Okay, you can get the BR to make sure that you get the positive sign lah. Okay, make sure that you get the positive sign. Faham ya? Okay, alright. So please be careful. Okay, kat sini. Okay, you kena make sure that you are able to translate it betul-betul. Decomposes dekat sini. That means you kena like what we did in tutorial last time. Okay, so decomposes kan? Decomposes. So maksudnya kita nak translate delta T, okay, is equal to alamak panjang ceritanya. You have to find this one first. Okay. find the delta NOBR first. Okay, so 2.4 times 10 to the power of 2 gram NOBR. Find the mole. Okay, 1 mole of NOBR. 109.91 gram. Okay, and then should we proceed further? This is only the mole. Yeah, we can divide this one with the concentration later on. Okay, tak apa. Okay, maybe we can use mole and OBR first. Okay, right. What's the mole, guys?
Medium. Macam
Salah.
terbalik lah.
Terbalik. 1 mole. Okay, nampak kita boleh identify sebab bila kita nak potong, kita tahu kita salah sebab bila kita nak potong, kita tak boleh potong. That's the good thing bila pakai dimensional analysis kalau you tak ada unit, you akan tekan di calculator. See? Okay, gram berapa, guys? 2.4 divided by 109.91 gram.
2.18.
1.2.18.
2.18.
Mole. Yeah. Okay. All right. So to get the concentration, because we already know that this is delta NOBR. Okay. Oh, you don't. Keep. Okay. Okay. Now we want to find the concentration. So 2.18 mole NOBR divided by, this is the concentration, okay? 2.0 times 10 to the power of 2 times 10 to the power of 3 liter. Okay? Bila nak tukar pada liter, divide kan? Okay, betul. So, berapa ni? Dapat, what's the value here? What's the molarity for this one? Guys?
10.92.
10.92. This is the molarity for NOBR. Okay, all right. So molarity for NOBR. So this one is equal to 10.92 molarity divided by 5 minutes. This is already delta NOBR. Delta T is 5 minutes. Okay, so you divide these two, you akan dapat this one. Make sure bila you translate tu, you ada this negative sign sebab dia decomposes kan, dia reactant kan. So when you translate this, is already inclusive the negative sign. So berapa kat sini?
2.18.
2.18 molar per minute. Please be careful, okay? The unit that we assign for the time, okay? All right, so this is the negative with is negative of delta NOBR over delta T is equal to this. Then, like I told you in a tutorial last time, okay, so this is like you bawa masuk ke dalam ni lah. But make sure that you have the bracket, okay? Don't just have tolak and then tak ada bracket. That is wrong. Itu salah besar tu. Sebab you bracket means it is multiplication reaction. Okay, don't simply just do this. 1/2 tolak NOBR delta T. Don't do this, guys. Ni salah, ni operasi tolak ni. When you have this bracket, it shows that this is multiplication reaction. Okay, sebab saya ada
Madam,
ya.
nak tanya sebab jawapan ni minta dalam second. So minit tu tak payah tukar ke dulu?
Dia minta dalam second. Okay, you kena tukar. Aduh, tak perasan. Okay, you have to change. Okay, you have to change in this 5 minutes. You have to times with 60 seconds lah. Okay, kena. It depends on the question. Okay, saya tak perasan. Okay, alright. So you have to times with 60 seconds, and then this one change to berapa? Berapa jawapan dia? 2.18 still?
0.036.
0.036 molar per second. Okay, alright. So this one you boleh translate into this. Okay, and then ataupun remember saya ada cakap dua cara kan. So ini saya tunjuk cara pertama. Cara kedua adalah the moment you nampak je that this is for reactant, this is the rate kan, you boleh tambah the negative here. You boleh jadikan dia negative 0.036 molar per second. This is option number 2 where dia akan cancel. Option number 1, you translate this one is equal to 0.036, the positive value. That is option number 1. Option number 2, where you add in the negative sign. Okay, so selesaikan 1/2 so that you can get this BR. Right? Ini option number 1, is it? Yeah. Okay, bukan option number 1. Ini cara pertama untuk nak solvekan question 1 ni. Okay, like what I've shown to you just now. Cari the concentration of NOBR and then insert into this. See? Is this. Make sure. Ni. Tapi student tak berapa mahir sangat menggunakan dia bila dia nak translate tu dia tak pandai nak letak negatif. Dia tak biasa. Tapi dia suka yang jenis rate letak negatif kat depan tu. Itu dia prefer kebanyakan student. Okay? Right, so you remember you have to times with 60 to convert into second. And then you have this relationship. Okay, so this whole thing ni ibarat kalau option number 1 masuk kat dalam ni, di negatif. Option number 1. Okay, option number 2, kat sini remain the negative. This one also got negative. Cancel. Also nampak at the end you should get positive on this side. Okay, alright, this is cara number 2. Cara number 1 dia cari for NOBR. See? Cara number 2, dia terus je buat stoichiometry to find the mole of BR2. Siapa yang buat cara ni pun tak ada masalah. Boleh. It's not a problem. Okay? So you from the beginning you already relate the NOBR dengan BR2. So you terus dapat mole for BR2 and then you find the concentration of BR2 and then this is the delta T and then you insert into the average rate, formula of average rate. Okay, so this is the final value. Okay guys? Okay, macam mana? So far so good? So far so.
Okay je, madam.
Okay, alright. We don't have a lot of practice related to this differential rate. Okay, as you guys notice dalam tutorial kita, ada 2 je soalan tu. Dekat dalam checkpoint kita, ni je lah. Okay, so if you could find practice on this, you'll be great lah. Okay, for you to practice. Okay, right, so moving on. Okay, factors that affect reaction rates. Okay, so we have one learning objective for this one. Okay, make sure that you are able to explain qualitatively the factors that affect the reaction rates. Okay. Okay, so during a reaction, during a reaction, bond will be formed, okay, and also bond will be broken. Okay, so ada bond formation and also bond breaking occurs simultaneously, serentak. Okay, so the old bonds are broken and the new bonds are formed. Okay, some reaction are fast by nature and others are slow. Ada reaction by nature dia memang fast, some reaction by nature dia memang slow. Okay, like for example our petroleum, the formation of petroleum. Okay, so those are reaction to produce a petroleum though really takes very long time. okay, in order to produce petroleum, berapa million years, okay, so that dia boleh produce a good quality petroleum. Tapi kalau tak good quality pun, dia still juga requires very very long period, okay. So itu kenapa? By nature, okay. By nature memang dia slow, macam kita lah, okay. So we are different kan, each one of us unique ataupun different in some ways, okay. So ada yang suka ni, ada yang suka tu, so dia memang by nature. Okay, ada yang laju slow dalam matematik tapi laju in chemistry. Okay, right. Like for example, rusting of iron takes 7 to 8 months. So this is also considered quite slow. Okay, ataupun apa nama tu, because it takes a longer period for the reaction to take place. Whereas fermentation of glucose takes a week, okay, sodium react with water takes a few seconds. So these are examples of reactions, reaction by nature. Okay, so the shorter the time, by right, the faster the rate. Okay, rate is inversely proportional with time. So when the time taken is longer, that means the rate is lower, and vice versa. Okay, because it is inversely proportional. Okay, so what are the factors that can affect the reaction rate? The first one will be the concentration of the reactant. So the rate of both homogeneous and heterogeneous reaction are affected by the concentration of the reactant. Because why? Because it affects collision. For reaction to take place, okay, they need to collide. The reactants, okay, need to collide among themselves so that the bond can be broken and also the bond can be formed. Okay, so that's the only way for product to be formed. They need to collide. So logically speaking, the more collision, that means there is a high probability for product to form. So how can we increase the collision? Okay, paling senang, we increase the number of particles colliding. How do we increase the number of particles collide? By increasing the concentration of the reactant. Okay, so the key word here is the collision. We want to increase the collision. How can we increase the collision? By adding more particles, by adding more reactant. So by adding more reactant, in a way, what we are trying to say is that we have to increase the concentration. By increasing the concentration, they will collide more. Okay, so therefore the collision rate will increase. Okay, number 2, temperature of the system. Okay, almost all chemical reaction occur faster at higher temperature. So this is very general statement, okay. You should know why temperature can help and can help in increasing the reaction rate, because temperature provide energy. Temperature increase the kinetic energy, because they provide extra energy dekat situ kan. But how do we increase the temperature? Normally by heating the system. Kita heat the system. Bila kita heat the system, what we are actually doing is that we are adding energy to the system. So system tu, reaction tu is gaining, dia dapat extra energy from outside. So what happen bila dia dapat extra energy? Dia become hyper kan? Okay, dia become hyper. So they tend to move faster. Bila they move faster, the speed become faster. What happened to the collision? They will collide more. Okay, they will collide more. They will, and then the probability, okay, the probability for the product formation will also increase. I said probability, because not all collision will produce product. Dia collide tapi not necessarily produce product. That is what we call effective collision. Kita pernah belajar ke effective collision? Pernah ke belajar guys? Semester 1? Macam familiar. Yang kita belajar transition state tu, ada ke?
Saya ingat tu Z effective.
Z effective. Z effective tu topik tu. Yang dia tak ada yang dia kena naik, dia kena activation energy tu. Tak ada kot, belum.
Yang profile diagram ni ke madam?
Ya, dekat profile diagram tu yang di transition state, nama dia activated complex. Have we?
Oh, itu tak adalah. Kita
Belum
belum.
lagi madam.
Belum lagi belum. Okay. Rasa topik ni kot. Okay. Yeah. Okay, so not, okay. For a start saya bagilah idea tu, okay. Dia tak semestinya when the collision take place, of course it will produce product. No, not necessarily. Okay, so during collision pun ada some rule that the particles need to obey in order to produce product ataupun effective collision. We call it as effective collision. Effective collision means collision that produce product. Okay, alright. So let's just put that aside first. Later kita masuk dalam topik tu baru kita discuss in detail. But what I want to highlight is that since statement dekat sini is very very general, maybe you can add in why. By adding temperature, by increasing the temperature of the system will help increase the rate. Okay, it has something to do with the kinetic energy, and it increases the speed of the particle and increase the probability to increase the collision, and the collision rate will be higher. Okay, all right. The third one will be the presence of catalyst. Okay, the presence of catalyst. Okay, ini patutnya kita tahulah. Kita tahu catalyst is pemangkin. In Malay, we call it pemangkin. Maksudnya the purpose of having catalyst is to normally is to increase the rate of reaction. Okay, so that is the purpose of adding catalyst into the system. So kita ada juga negative catalyst di mana kita nak make sure that kita nak stop something from happening. Okay, we add in this catalyst, this type of catalyst. Kita ada positive catalyst dengan negative catalyst macam tu. Okay, but normally catalyst is added in order to increase the rate of reaction. Okay, so catalysts are substances that increase the rate of chemical reaction without being used up. Okay, at the beginning you add in the catalyst. Okay, and then when the reaction completed, okay, when the reaction stop, the catalyst will still be there. Dia tak habis. Maksudnya dia tak gone. Dia will still be there. Okay, so that is what it meant by without being used up. And sometimes we can even reuse the catalyst. Okay, we can even reuse the catalyst. So that is very economic. Okay. And then the fourth one will be the surface area. Increasing the surface area of a solid reactant increase the chance of collision between reactant particles, thus rate increases. Okay, all right, surface area. So when you increase the surface area, the collision will also increase because you have more surface area now. Katakanlah, yang ni saya ingat kita pernah belajar yang chemical bonding, yang the intermolecular forces. Remember last time the London dispersion forces yang ada, yang dia gemuk, dia bulat dengan dia panjang tu. Tu saya ingat Okay. So kenapa yang bulat ni dia punya boiling point dia rendah compared to the one yang has yang longer version of the same molecular formula but different structural formula. It's because of the surface area. Okay, so the larger the surface area, by right, the intermolecular forces can be formed more. The smaller the surface area, by right, dia punya interaction, the intermolecular forces form is less. Okay, so the same understanding we apply for this rate. Okay, so the more surface area we have, the more collision that we can get. Okay, so imagine this is a chunk of cube ataupun a bulky cube. Okay, where you have yang surface area yang exposed lah. This would be your surface area lah. Okay, so this is how much surface area that you can get from a chunk of cube. What if you cut this cube into smaller pieces? You potong-potong ni kan into smaller cubes with 0.01 cm edge length. Ni siap dia ukur lah kan. Give 1 million cubes. Okay, so you bagi kecil and then you 1 million cubes ni you times dengan surface area dia, berapa you dapat dia punya surface area. This one total surface area is 6 cm kuasa 2. This one 600 cm kuasa 2. Okay, so mana dia punya total? Because all of them ni dekat dalam ni dia tak expose kan. Surface area is the one that being exposed. But bila you cut open, okay, you cut into smaller pieces. So all of the yang kecil-kecil ni they are all now exposed. Those are all surface area where the collision can take place. So the surface area is more now. Okay, so the surface area is more now, so that's why. And increasing the surface area, the rate will increase. Okay. Alright. Number 5, physical nature of reactant. So like what we had earlier. Okay. So by nature pun of course they will differ from one another. Okay. Alright. So like solid, liquid, or gas state. So this is by right the physical nature of the substance. It can be solid, liquid, or gas state. So the slowest will be solid lah. Okay, why is it the slowest? Because the surface area. Because you know solid is solid lah kan. So the one that being exposed will be the surface area that will provide the space, the area for the collision to take place. So solid dia yang expose lah, ni kata saya punya handphone kan. So saya ada atas ni, tepi, okay, tak tahulah nampak ke tak, bawah yang expose saja. Okay, yang dekat dalam tu tak expose. So dia kena remove the first surface area dulu and then expose the second surface area tu. Dia kena layer by layer. Tahu? Imagine when you are trying to burn kayu lah kan. Kayu kan, you nak bakar kayu yang besar. Okay, it takes time. Okay, sebab apa? Because the oxygen, okay, bila dia nak bakar tu, dia kena bertindak balas dengan surface area of the kayu tu. So, dia kena burn down layer by layer. So, layer 1 dah settle, baru go down to layer 2, baru go down to layer 3 and layer 4 and so on until it's all gone. So, lambat lah. Okay, lambat. Compared to if you have gas dengan gas. They can be bergaul, okay, dia boleh masuk, dia boleh diffuse and whatnot. So that's why bila gas react dengan gas, okay, if it is an explosive gas, split second dia boom. Okay, kalau kayu dengan api lah, kayu dengan api, you pernah tengok dia boom ke? Tak pernah kan? Mana ada, dia bakar. Tapi kalau gas dengan gas, and if it is explosive gas, it will explode. Okay? Alright. Ui, lama juga cerita pasal rate tu. Kadang random extra sangat. Okay? Alright. Okay, moving on to 1.3, the rate law and order of reaction. Okay, do you have question related to factors that affect the reaction rate so far? Ada soalan?
No, madam.
Yeah, so far okay.
Currently okay, madam.
Ya, Alhamdulillah. Yang lain yang senyap-senyap tu okey ke tak okey? Ha?
Okay, madam.
Okay.
Alhamdulillah
Okay.
okey madam.
Jangan tidur lah. Okay? Jangan tidur. Banyak sangat cakap madam ni mungkin mungkin tertidur. Okay? Okay, saya cuba. Just straight to the point. Okay. Next subtopic will be the rate law and order of reaction arc. As you can see from the learning objective, we have a lot of them. So bila banyak dekat situ, this is like I would call another jantung of topic. This boleh okay? Boleh kata jantung lah. Okay? Jantung ke paru-paru. Important lah. This is very important. Okay. So this is the one that normally, bukan normally, confirm. I would say confirm. Okay. Will be coming out in the exam. Okay. Make sure that you cover all of this learning objective. Okay. Moving on. Okay, so the rate law. So what is rate law and order of reaction? Rate law, like macam ada law pula dekat rate ni kan. Ya, begitu ya. The rate law express the relationship of the rate of a reaction to the rate constant and the concentration of the reactant raised to some powers. Okay, for example, for any general reaction, okay, assume this reaction, consider this reaction, okay? So we have A, B, producing C and D. So every reaction, guys, every reaction should have its own rate law. Rate law ni macam dia punya rules yang dia kena follow lah. Okay, dia by nature, they have their own rate law. Okay, so what we know is that rate is directly proportional to concentration. Kita tahu kan yang tu kan? So concentration increase, by right rate pun increase. Untuk your level, kita belajar untuk concentration increase, rate increase. Kita ada juga concentration increase, rate decrease. Ada, tapi kita tak cover that in our syllabus. Okay, for your level, rate is directly proportional to concentration of reactant. So we have A, B as reactant, C and D as product. Okay, alright. So dia directly proportional to concentration of reactant. Okay, I would like to stress here that it should be for the reactant. Rate law describe the reactant, not the product. Okay, not the product, only for the reactant. Okay, so rate is directly proportional to concentration of A raised to a power of M times concentration of B raised to a power of N. Okay, when we want to solve this relationship, okay, kita nak solve, that means kita nak transform into sama dengan, into equal. Okay, so that's why we have to have the constant there. Okay, rate is equal to K times concentration of A raised to a power of M times concentration of B raised to a power of N, because we have two reactant. Let's say if we have another reactant here, that means by right you should have Z lah. Okay, to the power of C maybe. Bukan C. X maybe. Okay, alright. So did you guys notice that the coefficient is not the same as the power? Okay, kalau dia sama, kita akan tulis itu A dan B kecil. A kecil, B kecil. Tapi dia tak sama. Please take note of this. Okay, alright, cuba tengok. K is equal to rate constant. M dengan N is what we call reaction orders. This is order. Okay, this is what we call order. Order ni dia ada nombor-nombor dia, ada value-value dia dekat situ. And ada karakteristik which later will be covered in the later slides. Okay, alright. So M dengan N, this one can only be determined by experiment. You cannot just simply take the value of the order from the coefficient of the balance equation. Don't do that. This is not the same as differential rate equation last time. Yang 1/1 tu, not the same. For rate law, okay, this is rate law. Okay, when you are asked to write the rate law, what you need to do is to rate, you have to write the rate is equal to K, A, referring to the equation that you have at the time. So A to raise to power of something, for example, M, B raised to power of n. M is not the same as A. Not necessarily the same as A. N is not necessarily the same as B. I said not necessarily be the same. Kalau dia sama, itu kebetulan. Faham? Because this one need to be determined by experiment, not just by extracting from the coefficient in the balance equation. Okay? Alright, so this is very, very important guys. Kalau you dapat sama tu, itu kebetulan sahaja. Bukan dia, oh, ini confirm ni, madam ni saja je tak nak kita nak buat kerja senang ni. Ya, tak apa, aku dah set lah. Dia mesti confirm sama. Terus je ambil daripada coefficient from balance equation. Don't do that. Okay? Jangan pandai-pandai. See, the values of M, the values of M and N are not necessarily related in any way to the coefficient of A and B. Okay, all right, so this is what we call, okay, delete first. This is what we call rate law, guys. This is the rate law. Okay, so it depends on the concentration of the reactants only, not the product. Because reactant is the one that we can control. That's why kita hanya ambil reactant sahaja. At the beginning, okay, kita hanya ambil reactant sahaja. We don't consider for the product. Because product, the formation of the product depends on a lot of things. Tapi kalau reactant, kita tahu. Because we are the one who prepared the reactant. Berapa yang kita nak masukkan, berapa the mass. So we know all the information related to reactant. So that is why, okay, for this one, we only consider for reactant. Okay, and then at the beginning of the reaction, the reactant punya concentration is at the highest. We don't have product at that time. Okay, so that's why rate is very, very prominent at the early stage of the reactant. Maksudnya dia menurun kan. Kalau reactant tu kan dia menurun kan. Kat yang tempat menurun tu dia very, very aktif pada ketika tu. The collision are all active at that time. Okay. Alright. So M dengan N ni is what we call order. Order. Dia ada perangai dia sendiri. Okay. What are the order that we are going to learn for your syllabus? Okay. So we have zero order. N is equal to 0. Okay, assume this one. Okay, consider this one. A forming product. Okay, so we are not concerned on the product, but we are concerned on the reactant. So how do we write the rate law for this reaction? Okay, rate is equal to K, concentration of A, because the reactant is A, raised to a power of N. So this is the order. You kena the order. Okay, so this is the rate law that need to be determined for this reaction lah. So this is the general rate law. Sebab apa? Sebab you tak tahu N tu berapa. Okay, alright. So ada banyak probability of N ni. Kita ada 3. Kita ada kalau dia zero order, if N is equal to 0, what if N is equal to 0? Kalau dia first order, what if N2 is equal to 1. And kalau dia second order. Okay, kalau dia second order. Okay. Ni kalau, okay. Itu kita akan kena determine. Later, kita akan tengok macam mana nak determine reaction tu dia order berapa. Okay, but before that, what we need to do is we have to identify the characteristic of each order. Okay. Alright, apakah perangai-perangai zero order, first order dengan second order ni? Okay, macam kita lecturer kan, kita nak identify apakah perangai-perangai student yang bermasalah ni. Kita kena identify dia. Okay, so sama macam reaction. Okay, you have to identify what is the characteristic of this reaction. Is it zero order? Is it first order? Is it second order? Okay, alright. So kalau dia zero order, how do we determine whether dia zero order or not? Okay, one of the criteria is that when you double the concentration of E, it will have no effect on the reaction rate. Okay, it will have no effect on the reaction rate. Katalah you buat eksperimen, okay, you buat eksperimen. You nak study the effect of concentration. So tadi kan kita dah tahu the effect of factors. Kita nak tahu the factors that affect the rate kan. So kita try concentration. What if kalau aku increasekan the concentration of the reactant, what will happen? Will it increase the rate? Yeah, ada case dia tak increase the rate, there's no effect. Okay, alright. So bila kita try. Okay, when we double the E, and then when we check the concentrate, the rate, kita check the rate, there's no effect on the rate. There's no effect. And then when you try to double it again, triple ke apa, there is no effect on the reaction rate. Which shows that reaction, dia punya karakteristik, dia punya perangai dia adalah the order of the reaction is 0. Okay, so maksudnya rate is equal to K A kuasa 0. Okay, maksudnya rate is equal to K. So because whenever you add in more, there's no effect on the rate. So the rate will become constant, betul tak? Throughout the constant, dia letaklah banyak mana pun, dia tak akan berubah. Ada perangai reaction yang macam itu. So janganlah membazir, you dah tahu kan. Janganlah pergi letak lagi membazir kita punya chemicals tu. So that is why it's very important for us to identify. Kalau kita tahu, kalau kita tahu reaction ni, ni reaction ni zero order. So there's no point you add more reactant into it. Okay, because you will wasting the chemicals because there's no effect on the rate. Wah, macam scientific betul kan? Okay, so kalau perangai ni macam tu, so kita boleh tahu that it is a zero order reaction. Okay, alright. What if kalau dia first order reaction? Apakah perangai kalau dia first order reaction? Boleh agak lah kan. Kalau dia N is equal to 1. Contoh. Okay, rate is equal to K A kuasa 1. Ataupun tak ada letak. Understood lah kan dia kuasa 1 kan. K is equal to A. Concentration of A. That means rate is directly proportional to the reactant concentration. So when you increase the concentration of A, okay, this concentration of A, the rate will also increase. Okay, that means when you double the concentration of E, it will also double the rate of reaction. So, you boleh imagine kalau you nak cepatkan lagi rate of reaction tu, tambahlah lagi. You doublekan lagi. Increase the rate. Letak lagi. Increase the rate. Okay, tapi kat situ you use a lot of resource lah dekat situ. Tapi kalau you want it to be fast, kan? You want it to be fast, then the option would be to increase the concentration of the reactant. Okay, alright. So the rate law of that reaction would be this one. This is the rate law. So kuasa 1. Okay, so kita boleh baca pattern dia tu. About second order, so second order lagi dahsyat lah kan. Second order reaction, N is equal to 2. Rate is directly proportional to the square of the reactant concentration. Maksudnya if we were to write the rate law, how do we write the rate law? Okay, don't forget the rate. If you are asked to write the rate law, you have to write rate is equal to K A kuasa 2. Okay, this is with respect to this equation just now. Okay, if we have 2 reactant, that means you have to find the order for the other reactant also. Okay, so ni you ada 2 order lah dekat situ. Tapi ni kita just nak kenal perangai reactant tu punya order. Okay, Alright, so rate is directly proportional to the square of the reactant concentration. When you double the concentration, it will quadruple the rate of reaction. Bila you double, the rate will quadruple. Okay, dia berganda dia punya tu. So ni lagi dahsyat lah. Okay, lagi cepat lah rate dia tu. Kalau you double kan, dia jadi quadruple. Okay, so thus rate is equal to Ka kuasa. This is the rate law. This is the rate law. Okay, so dah tahu kan perangai-perangai dia kan kat situ kan. Okay, jom. The decomposition of ammonia on a platinum surface at temperature is a zero order reaction. Okay, Alhamdulillah dia dah beritahu dah dia punya order. Okay, write the rate law for the above reaction. So this is the given equation to you. Okay, alright, so you have to write the rate law for the reaction. Remember, rate law only include the reactant. Okay, so how do you write the rate law with respect to this ammonia decomposition? Okay, so this is how you should write it. Rate is equal to K times concentration of ammonia raised to a power of 0. So 0, we know that when anything raised to a power of 0, it is equal to 1. Betul tak? It's equal to 1. So rate is equal to K. Okay, that means apa yang kita boleh conclude from this rate law? So it shows that the reaction rate is independent. Dia tidak bergantung on the concentration of the reactant. So whatever happen, whether you increase the rate, whether you increase the reactant or whether you decrease the reactant, it will not affect the rate. Okay, because it is a zero order reaction. Okay, all right. Okay, all right. So, like I said just now, the previous equation just now only has one reactant. That means you have only one order lah. One order only. What if? Okay, macam biasa lah. Equation is not as simple as that. Okay, so normally equation, the minimum reactant involved will be 2. Okay, so the question now is how do we determine the order of the reaction if we have more than one reactants involved? So then nak write the rate law and how do we determine the order? Okay, alright, tak apa. Okay, katakanlah soalan dah beritahu. Soalan beritahu for a reaction having more than one reactant, as you can see, we have 2 reactants. Okay, alright, in the above reaction, baca statement dia betul-betul so that you are able to write the rate law. Okay, in the above reactant, the rate is dependent, bukan independent the rate is dependent on the concentration of Br2, but independent on the concentration of HCOOH. Okay, so dekat situ dah boleh agak dah. Okay, first thing first, let's just write the general rate law for this equation. So the general rate law will be Br2. Let's say we assign the order of Br2 as M, unknown. Okay, kita buat dulu dia punya reactant. And then HCOOH, N. Okay, alright. So kita nak tahu, okay, now can we determine the M dengan N? Okay, let's go through the question. Dia bagi that information already. So we need to determine. Okay, dia kata Br2. Okay. Okay, so Br2 dia kata dependent. Dekat sini pun saya rasa information is not sufficient because dependent can be first order dengan second order, betul tak? Cuma kita tak tahu rate dia. Okay, rate dia kalau dia second order, dia still depend on the concentration kan. It's just that the rate will quadruple. Okay, kat sini, itulah pada saya soalan ni macam tak cukup information sebab dependent boleh jadi first order, boleh jadi second order. Okay, alright. Tapi mungkin dia cakap dependent on the concentration. If the rate increase, when we double the rate, when we double the concentration, the rate will also double. Maksudnya dia one-to-one punya relationship kat situ. So that's why we choose 1 lah. Okay, so we can, so now we can determine rate is equal to Br2 kuasa 1. Okay, how about HCOOH? But independent on the concentration of HCOOH. Independent maksudnya there's no effect if you increase the concentration of HCOOH, there will be no effect on the rate. So, kita boleh tahu
Zero
lah.
order.
Yes. Kosong. Okay, let's simplify this into a new rate law. So, it will be KBR2 without this one because this one is equal to 1. See? You need to have the rate, okay? Jangan kata rate law terus sama dengan KBR. Don't do that. You have to write the rate is equal to blah blah blah. Don't just simply buat sama dengan terus. Jangan buat macam tu. Okay? Alright. Kau apa ni? Kita kena habis 10.30 kan? Alright, any questions so far before we go further into determination of reaction order? Okay, so these are the steps to determine the order of the reaction. Ni, nak determine. Ini dia dah beritahu dalam soalan. Senang lah hidup kan? Tapi hidup tak semudah itu. Okay, dia dah beritahu M dengan N tu. So, we just need to write the rate law. But normally in the exam, of course, okay, you are the one who need to determine the order of the reactant. Okay, so yang itulah kita punya real deal later. Okay, do you have questions so far related to what we have learned up until now? Perangai-perangai itu dah kenal
Madam, dia punya untuk yang red law ni dia hanya dua reactant saja ke ada lagi?
Ada. Paling banyak 3. Rare tapi pernah ada 3. Okay, so bila ada 3 banyak lah you kena buat kan. So that's why normally we will only give 2 reactant because the steps that the steps required in order to find the order are still the same. Sama je nak cari dia punya order tu. So why do we need to give you more than 2? Okay, kenapa nak kena bagi lebih daripada 2 reactant dekat situ, sedangkan method to find the order is the same for all the reactant. So kita test you benda yang sama, so dia macam repetitive kan dekat situ kan. So that's the reason why kita bagi, normally we will only give 2 reactant, tapi we do have 3 reactants. Saya pernah tengok dalam exam kita pernah ada 3 reactant. Okay, 3 lah, 4 tak pernah. Melainkan dia ada tricky question ke apa kan. Okay, any other question? Okay. Alright, so there are 4 ways, 4 methods that we can use to determine the order of the reaction. Okay, the order of the reaction, or with respect to each reactant, because each reactant has its own order. Okay, so kalau the order of the reaction, kalau kita kata the order of the whole reaction, it will be the total order of each reactant. Okay, alright. So contoh lah macam ni kan. Kita ada 1, kita ada 0. So the reaction order for this one will be 1 plus 0. 1. Ataupun kita panggil overall order for this reaction. It will be equal to 1. 1 plus 0. It can be 1 plus 2 equal to 3. After all, you kena just totalkan sahaja kan. 0 plus 2 is equal to 2. Totalkan sahaja. Total order. Okay? Alright. Kalau ada 2 lah dia punya reactant tu. Okay, so we have initial rate method. The word initial rate method, that means the rate is very, very prominent at the initial part of the reaction. Sebab kat situ yang paling aktif sekali kan. Kan dia very cerun kan. Itu kan dia very dia punya slope dia tu paling apa nama tu? Steep. Okay, steep portion. Sebab dia paling aktif pada ketika tu. And then dia dah start dia punya curve dia tu dah start landai. Macam tu. Dah tak aktif sangat lah tu. Okay. That would be initial rate method. And then unit of rate constant. Okay, so from the unit, we are able to determine whether it is a zero order, first order and second order. Ya, boleh from rate constant. So mungkin ada soalan, kena hafal ke macam tu? Hafal lagi bagus. Tak hafal, it's not a problem. You may derive from the formula. Okay, alright, graphical method. Of course lah kena pakai graph paper, okay? Half-life method. Okay, alright, so we are going to cover all of this. Okay, let's start with method 1, initial rate method. This is the most commonly asked in the exam lah. Consider the reaction A plus 2B producing C plus D. So the general rate law, tambah sini. Okay, the general rate law can be written as this. So rate is equal to KA, because we have A, we have B. Okay, alright, so we have A and B. And then we do not know what is the M, what is the N. Okay, don't just simply take from the coefficient, guys. Okay, so M dengan N, kalaupun katakanlah later dia tersama, itu kebetulan saja. Okay, dia bukanlah saya sengaja nak menyusahkan hidup awak, saya tak nak beritahu rahsia tu, saya nak awak belajar kira-kira. No, tak ada. Okay, itu kebetulan sahaja. Okay, alright, so this is the general rate law. So A to the power of M, B raised to the power of N. Okay, so to determine the values of M and N, a series of experiments. Remember last time, M and N can only be determined through experiment. Okay, but that doesn't mean that you kena pergi buat eksperimen kejap untuk nak dapatkan M dengan N. Taklah, kita bagi you data, the data of experiment, and then you determine from there. Okay, so a series of experiment was conducted in which one of the reactant concentration changes while the other is kept constant. So this is the method how we can determine the order of with respect to A ataupun B. Cara dia adalah, you will be given a set of data. Okay, alright, so how do you choose? How do you determine the order? Okay, so you are going to select the reactant that yang berubah. Okay, you have a series of reaction. Okay, reaction 1, experiment 1, experiment 2, experiment 3, experiment 4. That is what we call series. Okay, so experiment 1 ada dia punya rate, initial rate dia. Experiment 2 ada initial rate dia. Okay, so cara dia adalah you akan pilih satu tu you akan cap constant, the other one tu you yang berubah. Tak payah cerita je, tengok contoh. Okay. Okay. We may come back to that statement later. Okay. Alright, so this is the series of experiment that will be normally given to you. Okay, so that you can determine using the initial rate method. Okay. Remember, our target is to determine the order of A and B. So these are the rate, and these are the initial concentration. Okay, like I said, initial rate method at the beginning of the reaction, and then initial B. Okay, alright. So how do you determine this? Okay, roughly. Cuba kita tengok kita tengok rate dia. Okay, kita nak determine the order of B. We want to determine the order of A. Okay, that means we have to fix the concentration of B. Okay, so that ialah macam you nak masak kan, you nak tahu effect of asam jawa dengan asam keping. Asam jawa dengan asam keping bila you letak dekat asam pedas. Okay, you nak letak. Bila you nak main these dua punya variable, adakah you akan usik ingredient lain dekat dalam asam pedas you yang sedap tu? Sedapnya asam pedas. Okay, adakah you akan kacau the other ingredient in your asam pedas? No kan, you will fix the ingredient that you only play around with the asam jawa and asam keping. Okay, itu yang maksudnya you akan play dekat initial A, maksudnya concentration of A ni you ubah-ubah, but B, okay, you choose yang eksperimen yang B dia fix, which is 1 dengan 2. Ataupun you can also choose 3 dengan 4. Okay, tak kisah mana-mana. Tapi that's the idea of it, okay. So you akan choose concentration yang fix so that you are able to study ataupun to determine, okay, the order of A. Yang ni berubah. Kalau ni fix, you boleh nampak okay, kalau this one is fix, B tu tak berubah, A berubah. Can you guys see the effect of when we change the concentration of A, what happened to the rate? From 2.5 increase to 5. This is double already. Okay, this is already double. From 2.5 to 5, nampak tak what happened to the rate? The rate also dah double. Boleh dapat idea tak? So dia order berapa? A order dia berapa?
2.
2. Ya ke 2? Bila doublekan the concentration, the rate pun double. Dia follow. Nampak? Ni double, dia pun double. Kalau 2, kalau order dia 2, rate tu quadruple, lagi tinggi. Ni order berapa ni, guys?
1.
1.
Okay, ni order dia 1. Tapi provided you janganlah usik yang ni you cap constant lah. You fix the concentration. Okay, alright. So same goes to when you try to solve for B. You nak cari B kan, you nak cari order of B. You akan pilih A yang constant. Sebab you jangan usik A, you nak main dengan B je, you nak check B ni kalau kita ubah-ubah dia punya concentration ni, is there any effect on the rate? Macam asam jawa dengan asam jawa dengan asam keping tadi, jangan ubah yang lain, pergi ubah bendi lah, pergi ubah daun kesum lah, habislah awak punya asam pedas awak tu. Okay. Sorry. Okay, alright. So if you want to determine the order for B, you may choose eksperimen 1 dengan eksperimen 3. Okay, 3 and 6 dia mesti berbeza lah. Okay, ataupun you may choose 2 and 4. Sebab 5 dia sama dia fix. Okay, so that you be able to determine the order. So boleh nampak tak? Okay, if this one is fixed, katalah kita ambil 2 dengan 4. Okay, 2 dengan 4. Okay, A is already fixed. Okay, how about B? The concentration is increased, okay, from 3 to 6. 3 ke 6. So what happened to the rate? The rate will also increase. Nampak? 3.5 jadi double kat situ. So, boleh dapat idea? Apakah ciri-ciri order untuk B?
1.
Idea tu dah dapat kan? So maksudnya from there we be able to determine. Tapi macam mana nak tulis? Cara nak tulis dia adalah begini. Macam mana you nak put on paper so that examiners be able to check and then give mark lah. Yang ni kita just tengok. Oh, boleh agak dah ni. Tengok pun tahu. Tapi tu dalam otak. How do you transform that in paper so that kita boleh check? Okay, so that's the idea of it lah. Okay, alright, so to put on paper, okay, in the experiment, B is kept constant for experiment 1 and 2. Okay, you may choose nak buat A dulu ke, nak buat B dulu ke, tak kisah, because at the end of the day, you are required to write the rate law. Last kali nanti, kena buat balik rate law yang dah ada value of order tu. Okay, alright, so remember, buat balik. The order rate is equal to KA kuasa M, B kuasa N. And now, okay, to determine M, the order with respect to A, okay, compare experiment 1 on and 2. Okay, you nak determine A, you nak determine A kan, that means B should be kept constant. Okay, B tu kena, that's why you pilih rate 1 and rate 2. Okay, so rate 2 over rate 1, rate 2 over rate 1. Dia boleh juga terbalik. Tapi kalau you terbalik, nanti you susah nak kira kat sini. You mungkin kena pakai log. Ni main kuasa dengan log ya. So, ada soalan mungkin, madam, boleh tak saya nak rate 1 over rate 2? Boleh, it's not a problem. Okay, but maybe you akan ada possibility sebab nombor tu tak cantik. Dia mungkin 0.5. You nak cari kuasa 0.5 macam tu susah. Jadi you may need to use log. Okay, tapi tak ada masalah. Okay, so what you need to do is rate 2, this is the rate law, right? Rate 1, this is the rate law. Ni main ratio. This is what we call ratio. Okay, you tulis balik the rate law tapi concentration ni mesti with respect to experiment 2 lah. Rate 1 ni with respect to experiment 1. Okay, but remember tadi B kan rate 1 dengan rate 2 just now dia sama. Okay, let me clear everything off first. Okay. Dia eksperimen 1 dengan eksperimen 2 kan. B dia nampak tu sama. Okay. Alright, so that is why B ni cancel. And then after all, dia ni N kan? And B will be cancel out. So that's why B tak ada kat sebelah ni. We don't have B here because it has been cancelled off. We only have A. And then even the K guys will also be cancelled out. But K constant kan? So dia boleh lah cancel. So that's why kita main ratio dekat sini. And you are left with this A sahaja. A2 dengan A1 sebab kita nak determine the M kan. Alright, so that's why dia bagi begini and then you factorize, so M letak dekat luar sebab atas dan bawah dia sama kan, so M letak dekat luar. Okay, so this is the time for you, so you are left with this one dengan this one. Dekat sinilah you akan isi the values from the data, from the table just now. Common mistake student made. Dia salah transfer data. 3.5 pergi ambil pula value lain. Itu memang common mistake. Please check very, very carefully guys. Okay, alright, don't forget the unit because you need the unit. Even though it will be cancelled out, you have to have the unit. Okay, because dia cakap rate guys tu. Okay, dia tak cakap value, dia cakap rate guys tu. So you have to have the unit. So cancel out. This is A. Eksperimen 2 kan, ini number 2, ni 1. So ini yang nombor 2 punya value over number 1 punya value. Okay, so you akan dapat 2 is equal to 2 to the power of M. So how do you determine this? Okay, 2M. So M is equal to 1. Kalau you buat terbalik 1 over 2, you mungkin dapat 0.5. So 0.5 leceh lah, you kena pakai log lah. You still akan dapat 1 juga. Okay? Ya, begitulah. So, cara yang sama kita apply untuk B. Okay, but this time around we're going to fix the A, the concentration of A. Okay, so kita pakai rate 3 and rate 1. Boleh juga you nak pakai yang lain pun tak apa. Asalkan the most important thing is that A should be fixed. The value of A should be fixed. Okay, because this one K cancel out, this one cancel out because this value is the same from the data. Okay, so we have only this B from experiment 3 and B from experiment 1. So you hanya ada ini dan ini sahaja, you factorize kan, okay? Alright, so and then you masukkan data, okay, and then you determine the N. See, 2 to the power of N. Ni bila you dah solve for this one, you akan dapat 2 is equal to 2 to the power of N. So 2, okay, is also equal to 2 to the power of 1. 2. So N is equal to 1. Okay? Alright, don't forget to write the rate law. The real rate law. The real rate law. Okay, so K is K times A to the power of 1, B times raised to a power of 1. So the overall order will be 1 plus 1 is equal to 2. Okay, guys? Alright. Okay, maybe you can try out this question. Okay, any questions so far related to this? Lebih senang. Harap-harap soalan keluar lah macam ni Okay. Memang common question asked lah. Memang commonly asked in the exam. So, kalau dia keluar macam ni, rezeki awak lah. Okay. Kalau salah tu maksudnya careless. Salah kira, salah transfer, all of those. Okay. Alright, maybe you can try out this one. Guys, cuba try before I leave you with the rest of the checkpoint. Cuba try. Sikit je data yang kita ada ni Okay, 2 minit. Okay. Okay, are you done, guys? Masuk. Hello. Krik. Dah siap ke?
Dah ada.
Dah. How about the rest?
Dah, madam. Done.
Dan 2. Lagi? Girls? Tak ada wakil pun girls. Hai girls, tak siap langsung ke? Tak ada wakil lah. Aduh, malu lah macam ni. Ada tak?
Okay dah, madam.
Dah Okay, yang lain? Dapat sikit lagi 5 orang respon tu. Whether you guys dah siap belum? At least A.
Dah, madam.
A, 2. Lagi?
Dah, madam.
3. Next.
Dah, madam.
4. Lagi? Last one.
Done, madam.
Okay. Kan ni kan azam baru. Okay. Kena respon. Dah siap? Saya tanya kan. Bukan saya suruh baca kepala otak saya. Saya tanya. So kalau dah siap, respon. Kalau belum siap, pun respon. Supaya saya ni, budak ni, buat apa kat situ? Senyap aja kan. Respon. Okay, and then one more thing, I really advise you, okay, walau saya tak tahu awak buat apa kat sana. Kita kan virtual. You kena buat. Jangan malas. Buat, paksa. Gigihkan diri. Mungkin this is the only time yang you buat revision. Tanda you demam ke apa later, tanda you tak ada mood ke, you apa ke, this is the only memories yang you ada. Kalau you tak buat, you don't have that memory at all. So please push yourself untuk buat. Try. Like I said, saya tak tahu awak buat apa kat sana. Saya suruh buat, mungkin awak tak buat. Awak tengok aja kan. Tak faham ke apa ke, tak tahu. Because there's no response from you guys. Okay, Sofa kata okay saja. So saya believe lah. Alright? Okay. Dia ada soalan ke tadi? Okay. Alright, so macam biasa, okay, let's look at the answer. Okay, so you are going to, so we have 2 reactants there. Okay, start with the general rate law dulu, yang unknown orders tu. Okay, alright, kita ada NO, we also have Cl2. So we have to choose the one yang ni lah. Okay, yang sama, fixkan, and so that we can get that one, that reactant, the order with respect to that reactant. Okay, alright, so kalau NO ni, kalau nak cari NO, kita kena fixkan Cl2 kan. Okay, kita boleh pilih 1 dengan 3. Bukan. 2 dengan 3 sebab dia constant. If you want to find Cl2, that means we have to fix the NO concentration. So we may choose 1 and 2. Okay? Alright, so you patut dapat this is with respect to NO. Okay, you punya order you should get 2 lah. This is for NO. Okay, and this is for Cl2. Okay, this is for Cl2. You should get N is equal to 1. Ataupun the order for Cl2 is 1. And don't forget to write the rate law. Dia suruh write the rate law tak? Oh, dia suruh determine the order of reaction sahaja. Maksudnya, if somehow you forget to write the rate law, the mark will not be deducted. Sebab soalan tak suruh. Tapi make it a habit, even though the question did not ask you to provide the rate law. Make it a habit so that if dia tanya, you have it already. Okay, sebab ada juga soalan boleh tanya write the rate law. So understood, kalau dia suruh write the rate law, bukan dia nak general rate law tu you must determine the order of the reaction. That one is counted as the rate law. Okay, alright. So this is the rate law. This is the final rate law. Okay, yang ini rate is equal to this. Okay, the second question ni, calculate the value of the rate constant K at negative 10 degrees Celsius. So this reaction is conducted at negative 10 degrees Celsius. Okay, you nak cari K. So you ada banyak sangat data kat sini. Which one? You nak pakai yang mana? Mana-mana pun boleh. It's just that if you choose experiment 1, you need to use the data from experiment 1 only. Yeah, you jangan pergi suka hati NO pakai eksperimen 1. CL2 pakai eksperimen 2. And then rate pakai eksperimen 3. Don't do that, guys. Okay? So you may choose, because you have the rate law already. You dah ada rate law kan? The order pun dah determine kan? So you can find out the key. So by using any of the data given, eksperimen 1 ke, eksperimen 2 ke, eksperimen 3, just insert the value so that you can get the key. After all, it's constant. You pakailah value nombor 1 kan, nombor 2, nombor 3. You should get almost the same answer. Sebab cari count constant kan. So eksperimen 1 kan, eksperimen 2 ke, eksperimen 3, dia patutnya constant ataupun almost the same. The value should be almost the same. Okay? Right, so this is the one lah. Wajib kena ada unit. Tak ada unit, tolak markah. Because later, second method adalah to determine from the unit of the rate constant. Okay? Alright, so saya tinggalkan awak kat sini. Kita ada banyak sangat contoh. Checkpoint 4. And then we have checkpoint 5. Okay, this is partial, guys. Nampak tak dia ada berapa? Ada 3, see? Ada 3 reactant dekat sini. This is partial tahun 2000. Lama juga, 5 tahun lepas ke macam tu. Cuba buat. Boleh buat tak? Kalau boleh buat, dah boleh masuk exam dah. Okay? Alright, so saya tinggalkan with this checkpoint. Make sure that you complete this checkpoint. So we will discuss it during our next lecture. Okay? Alright, so that is all. Any question? Alright, so if there's no question, I think that is all for today, guys. So thank you everyone for your kind cooperation, kind attention, and Assalamualaikum. Bye-bye.